Good evening, class. We are looking at college algebra practice test number 2, module 2, covering chapters 3 and 4. And here's the second part of chapter 3, functions. Extrema. What do we know about extrema? Maximum or minimum points on a curve. Local, also known as relative extreme value. Extrema, by the way, is the plural of the Latin extremum. A local minimum is the minimum value within some open interval. Local minimum occurs at a point C in an open interval A to B in the domain if f of C is less than or equal to f of x for all x values in the open interval. A local maximum is the maximum value within some open interval. Local maximum occurs at a point C in an open interval of A to B in the domain if f of C is larger than or equal to f of x for all x values in the open interval. So if we look at these two cases, local mean, local max, local mean, local max. That's the bottom line. Absolute, also known as global, extreme value or extrema, or either maximum or minimum points on a curve. Absolute minimum occurs at the point C if f of C is less than or equal to f of x for all x values in the domain. Absolute maximum occurs at the point C if f of C is larger than or equal to f of x for all x values in the domain. In other words, for a local, it happens in some open interval, not the entire domain. For absolute, it's in the entire domain. So, for example, when we look at these two cases, local mean, local max, local mean. This one is not only a local minimum, is also absolute. Local max, local mean, local max. This one is also absolute max. So in short, the peaks and valleys refer to local extrema, okay? And as far as being absolute, it can be absolute if it's referring to the entire domain, okay? By the way, the endpoints, they could be absolute, max or mean, but they are never local extrema. All right, so let's look at this example. This is a warm-up example. So this is the shape that is given, and we are interested in finding the following. Where is the function increasing? One way to look at it, if you assume the portion you're looking at looks like a line, and you know a line with a positive slope, right? And if it's this way, then with a negative slope. So as you can see here, this is where the function is increasing. So from -4 to 0, we write x is between -4 or 0 in an interval format from -4 to 0. We don't include the endpoints. Okay, at endpoints, anything can happen. Where is the function decreasing? I hope you see that this portion as well as this portion. So this goes from here to here, -2 to -4. This goes from here to here along the x-axis, from 1 to 3 to 6. Therefore, you say parentheses -6, comma -4, union 3, comma 6. And again, parentheses. Where is the function constant? It's wherever that it shows a horizontal line. In this case, this portion is a horizontal line segment from here to here. So from 0 to 3. Use the graph to estimate the intervals where the function is increasing or decreasing. Again, as a reminder, everybody, A function f of x is increasing on an open interval I if for any choice of x sub 1 and x sub 2 in I represents the interval, with x sub 1 less than x sub 2, we have f of x sub 1 less than f of x sub 2. Short, x gets larger, so does y. So as we move from left to right, obviously x gets larger. So what happens to y? Well, if it gets larger, it's increasing. If it gets smaller, it's decreasing. So a function f of x is decreasing at an open interval I if for any choice of x sub 1 and x sub 2 in I, with x sub 1 less than x sub 2, we have f of x sub 1 larger than f of x sub 2. So x gets larger, y gets smaller, and vice versa. Finally, a function f of x is constant on an interval I if for all choices of x in interval I, the values of f of x are equal. In other words, a portion that is a horizontal line. So we want to estimate where the function is increasing and decreasing. So let's look at increasing is here. So that means, and it stops here. Okay, so this is -8. This is -3. From -8 to -3 union. From here, okay, this point is number 3 to this point, number 7. So that's how you write. Decreasing is in between. This portion is decreasing from here to here, which is from -3 to 3. Determine any local max or mean. Well, local max, local mean. So this is the local max. So the y coordinate is 50, local max is 50 at x equals -3. So let me erase my work. So this point, basically, if you look at the coordinates, are -3, 50. So the way we would write it, maximum is equal to the y coordinate at x equals -3, or this is the pair. How do you answer it? The way they ask you. They may ask you for a pair. They may ask you just basically what is the maximum, or they may ask you at what. Whereas this one is the minimum. So if you look at this, minimum has coordinates +3, -50. So local minimum is equal to -50 at x equals 3, or you write the pair 3, -50. What about an absolute maximum? The endpoints can be absolute, and I hope you see that. These are local. This is an absolute max, this is an absolute mean. So absolute max is this point, and it is equal to 150. And it happens at somewhere between 6 and 8, 7 roughly. So absolute maximum is 150 at x equals 7, or you can say 7 and 150. Absolute minimum is this one. And this is probably 210, 20, 25, whatever that you read, I'm okay with that. Of course, negative. So -225. And the x coordinate is 8 to the left -8. So we're going to write absolute minimum is -225 at x equals -8. This is rough, okay? So it's just a matter of being able to read where the function is increasing, decreasing, local extrema, absolute extrema, and so on. By the way, if this continues indefinitely, both sides, we don't have an absolute max. We don't have an absolute mean, okay? For the following function, find f inverse of x. F of x is 2x minus 7, and we want to find f inverse. So what is the process of finding f inverse? Well, let's go through the process. Number one, Let's change f of x to y because it makes it easier to deal with. Number two, let's interchange x and y. So y becomes x becomes y. And this is it. We have the inverse function. However, normally we solve for y. Okay, right here we do have the inverse. So to solve for y, we are going to move the -7 and it becomes +7 and we're going to divide by 2. So y is x plus 7 over 2 and we give it the name f inverse of x is x plus 7 over 2. Now, what do we know about two functions where when they are inverse of each other? Their composite function is x. F O f inverse of x equals f inverse O f of x equals x. So we are going to prove that one of them, and by the way, one of them is enough. It's going to give us x, but I highly recommend you do the other one. In other words, I'm going to go over f O f inverse of x. You, for practice, you want to show f inverse O f of x is also x. So basically 2x minus 7 is f of x. We are going to replace the x with its inverse, f inverse. So we're going to replace the x with x plus 7 over 2, and obviously these two cancel each other. X plus 7 minus 7 is x. Is very straightforward. The other one is also fairly easy. So let's look at that one also. So f inverse O f is also extremely easy. So over here, we're going to write x plus 7 over 2 and replace it with the x with 2x minus 7. These two cancel each other. We get 2x over 2 or simply x, and it checks. So actually I did both, okay? All right, we're going to continue finding the inverse function for a different function, in this case, a rational function, and we start with the very first step, meaning we change f of x to y. By the way, I like to change x and y right here. So this becomes x, this becomes y, this becomes y. Sometimes you can just solve for x and at the end change it to y. Again, the other method if you come across it, is that you could solve for x, the finished job, x equals something as a function of y, interchange x. That works the same. In any event, since you want to solve for x, you're going to do the cross product. So x times y plus 2x equals y. And since you want to solve for y, let's move this one to the right and subtract it. You factor the y out from the right side and divide both sides by y minus x. And this is the inverse, so we give it the name f inverse. By the way we moved it, if we move it the other way, we could end up with the following: minus 2x over x minus 1. Please understand, if you multiply the top and the bottom by -1, this becomes minus. Okay, if you multiply by -1 over -1, you're not changing anything. So this becomes minus 2x, this is +1, this is -1, this is positive x. So -1 plus x or x minus 1. I don't like this because it has too many negative signs, but it makes no difference. This is also a correct answer. And to prove it, we're going to look at one of those, for example, f of f inverse. So we're going to go to this function, and we're going to replace the x with this function. We get 2x over 1 minus x over 2x over 1 minus x plus 2. We are dealing with a complex fraction. So to simplify a complex fraction, the best course of action is to get rid of the denominator, in this case 1 minus x. The LCD is 1 minus x. We're going to multiply the top and the bottom by 1 minus x. So what happens? Obviously, the numerator, these two cancel each other. And the denominator, when you multiply these two, 1 minus x cancel each other, plus 2 times 1 minus x. We are going to distribute. So this becomes 2, this becomes minus 2x. These two cancel each other. 2x over 2 equals x. So we proved it. And now, of course, F inverse OF, you don't have to do it. One is enough. I recommend you do that. Use function composition to verify that these two functions are inverse. If two functions are given and they say, okay, are they composite? Are they inverse function? You look at the composite function. So all you have to do, look at either f of f inverse. Okay, remember f of f inverse is equal to x. Just look at f of g, or you can look at g of f. Makes no difference. Both will give you, must give you x. So what is f of g? Replace the x here with x cubed plus 1. 1 and negative 1 cancel each other. These two cancel each other. And you get cube root of x cubed, and that's x, and you're done. And this is simple enough. We are going to look at the GOF of x, and we prove that one is x. That means this will replace the x here. As you can see, the cube root and the exponent, they cancel each other, you get x minus 1. These two cancel each other, you get x. And both of them prove. Again, you really don't have to do both. One is enough. I can't emphasize this enough, but I wanted to make sure that it's understood. We are given a function. We want to sketch its inverse. So sketch the inverse of the function whose graph is shown. Two functions are inverse of each other if you graph them on the same set of axes. They are symmetric with respect to the line y equals x, because x becomes y, y becomes x. They interchange. Okay, that's the idea. Okay, and why is it that it's reflection of that? Because this line, any point you pick, x is equal to y. That's why the name is, the equation is y equals x. So if you pick any point, and by any chance, if there is going to be a point of intersection between the two graphs, has to take place on this line, because again, you're interchanging. So for example, right now, because this line crosses the graph at some point, the other one, the inverse, must cross at the same point. Okay, so having said that, we are going to pick a few easy points that we can easily read from the graph. For example, this point, we can see that, again, this is 0, 0, everybody. Okay, so let me just make sure it's clear to everybody. This is the x-axis, this is the y-axis, so that's 0, 0. So we're going to go 2 to the left, and how many down? 4. So minus 2, minus 4. And we write negative 2, negative 4 is an element of f of x. This graph, let's call it f of x. Okay, the function, the red function it's y equals f of x. So with that being the case, if this belongs to this function, then which means f of minus 2 equals minus 4, then its inverse means f inverse of minus 4 equals minus 2. It means if you interchange these two, that means minus 4 comma minus 2 must belong to its inverse. If you don't write that, it's fine. But again, I want to make sure we understand the meaning of this, okay, because I've seen sometimes students getting confused. If you have a pair, it means f of minus 2 equals minus 4. The x coordinate is negative 2. The y coordinate is f of that point. So therefore, f inverse of negative 4 must be negative 2. That means interchange these two. Minus 4 comma negative 2 belongs to f inverse. So locate that point. So we are going to go 4 to the left, 2 down. So this point is 1 point on the graph of its inverse. Let's look at another easy point. For example, we can easily read this. It's located on the y-axis, 4 units up. 0, comma 4 belongs to f of x, which means f of 0 must be 4. And therefore, f inverse of 4 must be 0. Or just if 0, 4 is on the graph of f of x, then 4, 0 must belong to its inverse. Okay? So we are going to locate that. In other words, 0, 4 becomes the y-intercept, 4, 0 becomes the x-intercept for the inverse. Okay. Let's look at another easy point on the graph of f of x. This point, we go 1 to the left, negative 1, 3 up. So negative 1 comma 3. So we read this one as negative 1 comma 3. If this belongs to the function, that means f of minus 1 is 3. That means f inverse of 3 is negative 1. Or just, if you want to avoid them, that's fine. If this belongs to f of x, then it's just inverse that. Okay, put the 3 here, negative 1 here. And it must belong to its inverse. Okay. So we are going to find 3, go 3 to the right, and negative 1, 1 down, 3 to the right, 1 down, gives us this point. And of course, this, which belongs to the intersection of the line y equals x and the graph y equals f of x, also belongs to the inverse function. So connect these two and so forth. So you go like that. By the way, I just picked a few points. You can always pick more points. Just make sure the points that you pick, they are easy to read. Okay. Just for the sake of argument, this looks like 210. Okay, so you can say 210 corresponding to that would be 10. So let me just write that just as an example. Let me say, okay, this seems to be at 210, then we must have a 10 to take a look again. It's not exactly 210, it's maybe 2, 9.5 or 9.6, something like that, but you get the picture. All right. Sketch the graph of the function f of x, evaluate a few points, and determine the domain and range. This is called a piecewise defined function. You have pieces, 1, 2, 3 pieces. That means f of x equals minus x plus 1. As long as x is between these two numbers, then f of x equals 2 at x equals 1. That really means 1 pair, 1 comma 2. And then it becomes this function, f of x becomes x squared when x is larger than 1. So it's important to understand what's happening. So just to evaluate a few points. But the way I'm going to approach it as far as graphing, I'm going to graph each piece completely separate, then I'm going to put them together. But as far as picking up a few points, okay. Let's start with a bunch of points. Let's go -1, 0, 1, 2, 3. For example, for -1, it has the equality here, so you put it here. If I put -1 here, I get negative times negative, positive 1 and 1, I get 2. 0. Now, between -1 and 1, 0 belongs here. So if I put 0 here, I get 1. 1 is 2. It's just this one, 1 comma 2. If I put 2, because it's larger than 1, 2 squared, I get 4. 3, I put 3 squared, 9. Just to give you an idea, those are the pairs. But I want to show you how to actually graph this nice and easy. We are going to look at this top one, and we're going to call it y, or y1 equals minus x plus 1. I'm assuming no one has any problem graphing this line. You pick up a couple of pairs. Obviously, 1 is the y-intercept. That means 1 comma 0. What is the x-intercept? If you set this equal to 0, you get 0. So 0, 1, 1, 0. So 0, 1, 1, 0. By the way, if you see number 2 here, that means 4 tick marks. So 2 tick marks is 1. So that's the line. And I'm not going to pay attention to this limitation yet. I just want to come up with all three parts. This one is just, excuse me, just a pair 1 comma 2. Okay. And the last piece, it's a parabola, y or f of x equals x squared. As you know, a graph is that. Okay. Now, this is not the answer. I just graphed 3 different pieces. The top piece without paying attention to this, the second piece, and the third piece without paying attention to this. Now we want to pay attention to the limitation. So this line is good from -1 to 1. Okay. So -1, we already know it gives us 2. So if you go with -1, it should give you 2. So right here is good. And it goes all the way to 1. If I put 1 here, I get 0. But this one is a whole. So this portion, I want to make sure we understand what's happening here. Because of the equality here, this end is part of the graph. And because of the fact that we don't have equality, we put a hole here. We have that pair also, it's not a big deal. And then this is good for x larger than 1. So at 1, if I plug in 1, I get 1. So this point, everybody, is 1 comma 1. Let me just not a good one. Okay. So this point is 1 comma 1. But is it part of the graph of a parabola? No, because it doesn't have equality. So you have to put a hole there. So you put a hole there and it goes up the rest of it. So this portion is not. Now let's put them all together. So this is good. Okay. So is this point, and so is this part. So this is the graph. Okay. So a quick recap. If I'm graphing a piecewise defined function, I graph all pieces, and then I pay attention to the restriction. This is the fast and easy way to graph it. Now, as far as the domain and range is concerned, remember, domain, put this along the x-axis. So if you put this along the x-axis. This covers this one, -1, and the rest of them cover the rest on the right. So from -1 to infinity. And as far as the range, put it along the y-axis. I hope you see that it covers all the positive side. And over here we have a hole, so that's a hole here. In essence, the range would be 0 to infinity. 0 is not included. Bracket, the endpoints is included. Parentheses, it's not. Infinity, as well as negative infinity, they are concepts, therefore they will never get brackets. Find the average rate of change of f of x equals x squared minus 3x as we go from 2 to 4. Again, what we have been looking at. So if average is f of b minus f of a over b minus a, in this case, f of 4 minus f of 2 over 4 minus. So something we've seen before, it's not a big deal, everybody. So we should have an easy time understanding the concept as we have been dealing with that already. So having said that, we are going to plug in into this 4 and then 2. So 4 squared minus 3 times 4 minus 2 squared minus 3 times. And so let's see what we get here. So this is 16 minus 12. This is 4 minus 6. Okay, so 16 minus 12 is a 4. So this one is 4. And this one is -2. With this negative becomes positive. So 6 halves, which is 3. Now, we're going to do the same thing, but this time from x equals 4 to x equals 4 plus h. So we're going to find the average rate from x equals 4 to x equals 4 plus h. So let's plug in 4 plus h. And then 4, if you want, you can even use the fact that f of 4 was calculated here, okay? Which was 4. But in any event, so 4 plus h squared minus 3 times 4 plus h. So f of 4 plus h would be 4 plus h squared minus 3 times 4 plus h. Minus f of 4, we already have it. And then just write the denominator. When you write the denominator, it's important to know ultimately you end up with h only. Now 4 plus h quantity squared, and we are going to use a plus b squared, which is a squared plus 2ab plus b squared. So this is 4 squared, which is 16. 2 times the first times the last is 8h, and then h squared. Minus 12 minus 3h, and this is 16. So minus 16, this is minus 12 plus 12. I'm going to write it in this fashion instead of actually working this out, because you may notice this cancels out this one. This cancels out this one. Then you have in the numerator h squared and this 2, which is 5h. Now, if I factor the h out and drop it, I get h plus 5 as the final answer. Find the value of x if a linear function goes through the following points. We are given 2 pairs. The slope is given. And of course, just to remind everybody of, again, what we studied as far as lines are concerned. Standard form x plus by equals c, slope intercept form y equals mx plus b, point slope y minus y1 equals m times x minus x of 1. Just reminding you. Vertical line x equals a, the slope is undefined, has a x-intercept at a0. Horizontal line y equals b, The slope is 0, y-intercept at 0, comma b. Two lines are parallel if they have equal slopes, different y-intercepts are perpendicular if their slopes are negative reciprocal of each other or their product is negative 1. I hope everybody is okay with that. Just reminding you of that. And therefore, again, reminding you that the slope is rise over run y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or delta y over delta x, or rise over run. This is extremely important for the next course, so you want to really be comfortable with that. So having said that, and using that, we are going to go with this formula and say 6 minus 2, that's the numerator, okay, equals minus 4 minus x, that's the denominator, divided by, my apologies, 6 minus 2 is at top, minus 4 minus x is at the bottom, and that's equal to the slope, which is given us 3. We do the cross product. So 3 times this, 1 times this. Of course, 6 minus 2 is 4. And so we have negative 12, negative 3x. We add 12 to both sides, and we divide by negative 3x becomes negative 16 thirds, everybody. Negative 16 thirds. Very straightforward. I hope everybody's okay with that. Consider this scenario. A town has an initial population of 75,000. It grows at a constant rate of 2,500 per year. Find the linear function that models the town's population, P as a function of year T, where T is the number of years since the model began. It's really a simple case of y equals mx plus b. In this case, we are using different variables to represent this. So P of t is the population as a function of time t. The constant rate of growth of the function m equals 2,500 per year. This is the slope in essence. The average rate of change of y with respect to x, in this case, the average rate of p with respect to time. The initial value, the initial population, we start with 75,000, which represents the y-intercept, in this case, the p-intercept, if we're going to go with p. And the linear function, which is y equals mx plus b, it becomes p equals mt plus byt, because we are using the t as an independent variable instead of x. So p of t becomes 2,500 t plus 75,000. What will the population be 10 years from the beginning? So replace the t with 10. 2,500 times 10 is 25,000, with 75 becomes 100. 100,000 will be the population in 10 years. Of course, the assumption is that this will continue to add 2,500 per year. Well, monthly cost of a cellular plan depends on the number of minutes used and a flat fee. 410 minutes, $71.50. 720 minutes, $118. Express the cost C as a linear function of the monthly minutes used X. So first and foremost, they want us to use, remember, X comma Y normally, but now it's X comma C. C represents the cost. So I think it's really helpful to see that. So we're going to put the minutes first. So this would be 410, 71.50. This would be 720, 118. So these are the two pairs. Now, we want to find the cost function. So we are going to calculate the slope, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1 normally. However, in this case, because we instead of x comma c, if you want, you can write x comma y at top, calculate everything for y, and at the end, change the y to c if it makes it easier. So with that being the case, instead of y sub 2 minus y sub 1, we're going to have c sub 2 minus c sub 1. Therefore, we can say 118 minus 7150 over 720 minus 410. And we do the math. We end up with 3 over 20 or 0.15. We can go with either the fractional format or a decimal. Both of them are exact in this case. Normally, we have y minus y1 equals m times x minus x sub 1. This is the point slope. But remember, you can finish the job when you're done, put c instead of y, or just write here c minus y1. So c minus y1. So you pick, for example, one of them, this one, because this has a decimal. So let's go with this one. C minus 118 is m 3 over 20 x minus 720. By the way, when you're done, I highly recommend you check it with this pair to make sure you haven't made a mistake. And so 320 times x and 720 divided by 20 times 3, it's minus 108 because it has a negative sign. And we are going to move this, make it positive on the right side. So the cost is 3 over 20 times x plus 10, or just in case, if you wrote 0.15x plus 10, okay, if you use the decimal, it's just as good. What is the cost? Using 687 minutes per month, just plug in 687 instead of x. This x, replace it with 687 times 3 divided by 20, add 10, and you can get 113.05. Interpret the slope and the c-intercept. See, normally we say the y-intercept. Now it's the c-intercept. The c-intercept, of course, represents the fixed monthly cost. Okay. So that means no matter what, if we look at this one, let me erase my work first and then box this one. So if you look at this one, 10 means they charge us $10 even if we don't use any minute. That is the constant, the fixed monthly cost for the y-intercept. Now we call it the c-intercept. This is the variable cost. That means the slope that represents the cost per minute. It's 15 cents. I erased it, if you go with that one, make 3 over $20 or $0.15 or 15 cents per minute. Therefore, the c-intercept represents the fixed monthly cost or flat fee charged by company, which is $10. The slope represents the change in cost per minute of call for the amount of $0.15 per minute. And for us, that means 15 cents. It's easier to think of it that way. 15 cents per minute. The height in inches of a sunflower X weeks after being planted can be approximated by this function. How tall is the sunflower 8 weeks after planting? Just plug in. If I plug in 8, if this is the function that approximates the height after 8 weeks, I plug in 8. I get 6 times 8 minus 1/4 times 8 squared. This is 48. This is 64. 1/4 of it minus 16, and we get 32 inches. Find the average rate of growth from end of week 6 to end of week 12. So the average rate, okay. So f of b minus f of a over b minus a. So in this case, or f of x of 2 minus f of x of 1 over x of 2 minus x of 1. In this case, f of 12 minus f of 6 over 12 minus 6. So we basically plug in. So we could plug in 12, we plug in 6, and so this is 72. 12 squared is 144. 1/4 of it is 36, so we get 72 minus 36. This is 36, so is this one. 1/4 of it is 9, so this is 36 minus 9. And I hope you see that this is minus 36, this is minus 36 with 72 cancel each other, minus 9 plus 9. 9 over 6, or 3/2 units of the numerator over the units of the denominator. The numerator represents the height, the denominator represents the time in weeks. So 3/2 of an inch per week. Every word problem represent the proper units as you must.